Pemirsa, tumpukan sampah styrofoam atau busa memenuhi Kali Baru Barat, Jagakarsa, Jakarta Selatan sejak Kamis lalu.
Meski petugas sudah mengangkut 100 kubik sampah styrofoam, namun tumpukan sampah masih tetap terlihat di lokasi.
Assalamualaikum warahmatullahi wabarakatuh. Hello ladies and everyone, let us introduce ourselves. My name is Dzikra Lubna, Khairunnisa. I'm my partner, Naila, Azfa, Royyana. We are from Islamic State Senior High School, Dzikra. Do you know the impact of the practical use of styrofoam in the environment? As you can see at the beginning of this video, according to National Coordination Team of the Marine Waste Department Management, the amount of plastic garbage has been on the rise for the last 3 years, one of which is styrofoam. While the properties of styrofoam itself can last a long time because it is not easily degraded and can contaminate land, rivers, and oceans. From that, we make an innovation by using a degradable raw material on styrofoam with the title iBite Intelligent Biofoam Detector. Smart packaging for detecting beef freshness by understanding dragon fruit peel from sugarcane babies and plantain peel waste. Styrofoam is widely used because it's practical and economical. However, it is disposable packaging that will cause the accumulation of garbage in the soil, so they can cause environmental pollution. In an effort to reduce the negative impact of organic waste on environment, this research is intended to design solutions that can transform waste becomes a high-value product of biofoam. Biofoam or biodegradable foam made of natural materials, mainly plant-based ones like starch, which has properties that can degrade or broken down by microbes in the soil. In this study, the selection of ammonia from the plantain skin as a basic ingredient in the manufacture of biofoam because of its easy-to-reach and cheap resources and its properties, high biodegradability, non-toxic, and abundant in nature. Apart from that, this research also tries to utilize sugarcane bagasse. Sugarcane bagasse was chosen because it is easily to obtain and is often thrown away carelessly or burned, which will cause environmental pollution. Apart from that, making biofoam was innovated as an alternative choice that can be used to package fresh products, such as beef. Meat is one of the food products of animal origin that has nutrition. However, consuming unhealthy meat can cause a variety of diseases, for it requires a choice of meat that is healthy, fresh, and worthy of consumption. The freshness of the meat is the main factor in determining the quality of beef. It utilized the anthocyanin pigment from the red-colored dragon skin to make the flavonoid compound. In addition, its sensitivity to relatively high level of acidity is demonstrated by color change at each level of pH change from acid to base. The anthocyanin color sensitivity of dragon fruit skin can be used as an indicator to detect changes in the quality of food products, especially products that are vulnerable to damage due to exposure to temperature or light, such as meat. The first thing that must be done is to take starch for plantain skin and fiber from sugarcane bagasse. In the process of making biofoam, the first thing is mixing BVA with hot water, then following the other ingredients, magnesium stearate, starch, fiber, and stirring until homogeneous, with a ratio of starch and fiber of F1, F2, and F3. The finished dough is put into a mold and dried using an oven, which will then be tested for water absorption, biodegradability, organolepticity, leakage, photovoltaic, and impact. The biofoam with the best result would be used to test the freshness of the beef.
The indicator is made by making dragon fruit peel extract, then placing in the water bath to get a thick extract, which will then measure the pH and determine the absorbance value. Meat freshness testing is carried out using 3 procedures, namely direct mixing of methyl red, immersion of biofoam in indicator solution, and direct mixing of methyl red and dragon fruit peel extract by carrying out 2 treatments, namely placing pieces of meat then packing them in biofoam and covering them with LDPE film packaging, will be placed at room temperature and storage in the refrigerator.
So the results we got in this research include the biofoam water absorption capacity test aimed to determine the amount of water content that can be absorbed by the biofoam. The data shows that the more cellulose is used than starch, the higher the percentage of biofoam water content. The smallest absorption capacity was obtained by biofoam with formula F3, 1.25 gram starch, 5 gram fiber. Biodegradability tests carried out to determine the rate of degradation of materials due to the activity of microorganisms. Biofoam with the fastest degradation rate is in the formula F1, 1 gram starch, 1 gram fiber, which only takes 1 day to melt into one with the soil. The organoleptic test of biofoam shows that the more starch added, the darker the color of the biofoam will be. The surface of biofoam is also fibrous and hollow. In this test, the results showed that each sample had an unique surface because the biggest fibers were not smooth because its printing was done manually by hand.
A leak test is carried out to determine the ability of biofoam to retain water. From this test, it was found that the F3 formula had the best result with no leaks. The impact test result with the greatest durability were F1 formulation with an impact strength of 3.57 kJ per square meter. In an effort to increase the level of hardness and softness of biofilm, fiber is very influential. The more fiber used and the greater the level of hardness and softness of the biofilm. Meanwhile, the result of assay determination using UV-free spectrophotometry is produced an absorbance value of 0.029 mg per gram. In the picture, the color change in treatment 1A is biofilm with the result only experiencing a slight color change, namely thicker than the biofilm before testing. In 1B, there was no color change compared to biofilm before testing. Treatment 2A showed that there is a slight yellow color in the middle of the biofilm compared to the color of the biofilm before the test, which was completely red. Treatment 2B experienced a complete change, namely dark yellow at the edge of the biofilm and pale yellow in the middle of the biofilm. Treatment 3A has a slightly pale yellow color in the middle of the biofilm compared to the color of the biofilm before testing, which was dark red. Treatment 3B experienced a color change in the middle, namely yellow and a less intense red color at the edge of the biofilm. Biofilm used as a pH detector experienced the same pattern of increasing mean RGB. When the meat is still fresh, the mean RGB value will rise, but in the condition of the meat has started to change in pH, the RGB value will fall. And if the pH changes significantly, the condition of the meat is rooted. The mean RGB will rise again.
That's all our explanation video. Don't forget to support us in ISPO 2024. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.